Welcome again. Is it good? Is it visible?
Yeah.
Properly?
Yeah, it's visible.
Very close.
I'm not?
Yes, ma'am.
Yeah.
You better just.
Yeah, now it's good. Yeah.
Yes,
Is the board visible?
Yep.
Okay.
Yeah.
Welcome to physics class. Again, we just continue this nuclear force. This is nuclear force, the force that determines the motion of atomic electrons, right? So we saw what is the nuclear force right now. And then, you know, the familiar Coulombic force, right? What is the Coulombic force, you know?
F equals
Right.
Yes, ma'am.
Yeah, F is equal to, okay, there must be a force of repulsion or force of attraction, right? Then we have seen that for average mass nucleate, the binding energy per nucleon is approximately 8 million electron volts. We saw on that particular table throughout all the elements. So if you take an average, what is the energy, binding energy per nucleon? 8 million electron volt.
Yes.
Okay. So which is much larger than the binding energy in atoms. The nucleon energy is larger when compared to the binding energy per atom, right? So, therefore, to bind a nucleus together, there must be a strong attractive force of a totally different kind. Understood?
Yes.
So, from this observation only the scientists got an idea, since the nuclear binding energy is very high when compared to atomic, so that they come to the conclusion that what they said, to bind the nucleus together, you have asked, right? Nuclear fusion. To bind the nucleus together, there must be a strong attractive force of a totally different kind. It needs some energy to fuse together. And then after that it releases some energy also. Okay? That we'll see.
Okay.
Then it must be strong enough to overcome the repulsion between the positively charged protons. Right? In the nucleon, what is there? All are positively charged.
Yes.
What is the force of force will be? The Coulombic force will be, definitely it is repulsive.
Yes.
Clear or not?
Yes, ma'am.
So it is repulsive. So what they said, in order to overcome the repulsive force, but what they said here, strong attractive force. What is the meaning of that? Therefore, to bind a nucleus together, there must be a strong attractive force of a totally different kind. Right or not?
Yes, ma'am. அந்த
That-
repulsive force overcome பண்ணி
So the force should be attractive. Then only the proton and proton can be fused together.
Yes, ma'am.
That is very interesting fact. If a proton fused together means it is come close together with another proton. It is impossible. So that the force of attraction will be overcoming the force of repulsion.
Yes, ma'am.
So this is the difference, okay? Then, what is happening here? Many features of the nuclear binding force are summarized below. So these are all given. What is this? We have already seen that the constancy of binding energy per nucleon can be understood in terms of its short range. Okay? So we know that, right? What is the constancy of the binding energy per nucleon? That's what we have discussed in the previous topic. Why binding energy is constant? What? What is the saturation property?
அந்த நியூக்ளியான்ஸ் வந்து சுத்தி இருக்கிற நியூக்ளியான்ஸ் மட்டும் தான் இன்ஃப்ளூயன்ஸ்.
That is, what is that? That it says, if you add more nucleons, then what will happen? It won't affect the binding
It will
energy.
be
per
the
nucleon.
surface of
Yeah, because you are adding only it just moves on to the surface. It doesn't affect the influence of any neighbor atoms. So the binding energy per nucleon is constant. That is again discussed in this particular topic. Clear?
Yes.
So many features of the nuclear binding force are summarized below. Okay, so these are obtained from a variety of experiments carried out during 1930 to 1950. So most of the scientific discoveries and experiments carried over in this particular period only. So during 19th century. So after Einstein, so many experiments carried out in this field actually. In quantum mechanics, you might have seen so many experiments. As a result of this, the nuclear explosion came into existence. You know, our pride of India, who is mainly responsible for this Pokhran test and everything. Abdul Kalam. Dr. J. APJ Abdul Kalam ji. So he was a great renowned person who has got a very good knowledge in this nuclear explosion, and then he did that particular test on those days. It's very interesting. You can Google it and find so many interesting facts. Okay? So then, what it says here, what is the second point? So here. So the nuclear force is much stronger than the Coulombic force that you know. That's what we are discussing right now.
Yes, ma'am.
So, what is the nuclear force? Bringing one nucleus close to another nucleus. That is the nuclear force.
Yes.
That should overcome the Coulombic force. Okay. So, definitely it must be stronger. So, acting between charges or the gravitational forces between masses. Understood?
Yes, ma'am.
Then, the nuclear binding force has to dominate over the Coulombic. Again and again, the same point they are given. You just keep in your mind now. The nuclear binding force definitely it will be greater than the Coulombic force.
Yes, ma'am.
Or we can say the Coulombic force repulsive Coulombic force. Clear? So then, this happens only because the nuclear force is much stronger than again and again the same point. The gravitational force is much weaker than even Coulombic force. That also you know, right?
Yes, ma'am.
So you have discussed this particular topic in your first lesson. Do you all remember? You have compared gravitational force and the Coulombic force.
Yes.
Which one is greater? Everything gone in air for all.
மேம் அந்த ரேஷியோ மட்டும் தான் போட்டு
ரேஷியோல தான் நீங்க என்ன ஃபைண்ட் பண்ணுவீங்க ரேஷியோல? ரேஷியோ மூலமா என்ன தெரிஞ்சிட்டீங்க? Which is greater? Coulombic force is greater. Clear? That's what we have discussed. Is it clear?
Yes.
So gravitational force is much weaker than even Coulombic force. Clear, ma? So the first point deals with all these things. Then the nuclear force between two nucleons falls rapidly to zero. Okay? So the nuclear force between two nucleons falls rapidly to zero. Then what will happen as their distance is more than a few femtometers? What is femto? You have to go through all of you just take your class 11 book also along with us. You should go through your 11th book especially. Units and measurements are discussed over there. You just brush it up. Unless otherwise you can't even write the first JEE exam. Very tough for you. Understood? So both the things you have to just concentrate. Okay, then what it says, the nuclear force between two nucleons falls rapidly to zero. So when the nuclear force between two nucleons will be zero, if the two nucleons is far from it, that's all. If it's very closer, then it is stronger, that's all. Then, this leads to saturation of, again the same point is discussed. To remind.
Yes, ma'am.
So this leads to saturation of forces in the medium or a large size nucleus, which is the reason for the constancy of the binding energy per nucleon. Again and again, the reason for the constancy of the binding energy per nucleon is discussed. This is the saturation property of the nucleus. Clear? Then, a rough plot of the potential energy between two nucleons. This is the third point. As a function of distance is shown in the figure. You know that the potential energy. What is the potential energy? It is the work done in moving.
Unit positive charge from infinity to
That is potential difference. Right? What is potential energy?
the energy that is used to move the electron. Unit positive.
The work done is stored as a potential energy. That's all.
Yes.
It is stored. That means if a particle is, first of all, you may find the particle in one position. Okay? Then the particle is now in the other position due to the force. So there is a change in position.
Yes.
Right or not?
Yes.
The particle gets displaced from one position to another position. We are just talking about the positional change. Right? So this leads to potential energy. The object or a particle associated with potential energy means by virtue of its position.
Yes.
Understood? So what it says, okay, the potential energy is the minimum at a distance r0. See, this is r0, it is given here. Let us discuss in detail. This is R naught. At this point, the potential energy is minimum. Okay, so about 0.08. So they are saying near to 1. So this R naught is 0.08 femtometer. Then what it is given? And repulsive, right? Why the potential energy is repulsive? Definitely there is a inside the nucleus proton and proton. Okay. Then what it says, if they are separated by distance less than 0.8 femtometer. Okay?
Femtometer to meter conversion.
You can learn. Then if I am going to that particular thing, then that is taking time.
Okay.
Okay. So what is this now? What is this? What they are trying to say, trying to convince here? If they are separated by distance less than 0.8 femtometer. See, there are protons. Clear? Here one proton, here one proton. The separation between these protons is now 0.8 femtometer. This is the minimum potential energy.
Okay.
If it is very much close, that means the difference between the two protons is less than 0.8 femtometer, then what will happen? What will happen?
They ripple.
This ripple. If it is 0.8 femtometer, what it says? That force is attractive for distances larger than 0.8 femtometer. Understood?
Yes.
So this is the idea. So you must say in the graph which is attractive, which is repulsive. Let me know. Which is attractive, which is repulsive.
From the least point down.
This is the
Attractive point. Yes.
no, this is the limit. But to explain, this graph shows what type of force. At this particular area, what type of force it is. Attractive or repulsive? Repulsive, less than.
Yes, ma'am.
So how the repulsive force is? The repulsive force gradually decreasing when the distance of separation is gradually increasing.
Yes, ma'am.
Understood or not? This idea you must understood. Unless otherwise you can't able to answer the reason assertion questions. Some case based also will be asked. Okay. So what it insists, the separation. Okay. There must be critical separation we can say. That is 0.8 femtometer.
Ma'am, at the decreasing point, the attractive
Yeah,
0.8 femtometer coming.
That's what here. That is the
Kammiya repulsive.
Yeah, that's what the major difference between.
Yes, ma'am.
Since it is proton and proton.
Ma'am, in the axis the distance and basically.
No. That's what this difference you must take into account. So if the difference is 0.8 femtometer, that is the critical point where the potential energy is minimum.
Yes.
If it is less than 0.8 femtometer, the force will be repulsive. Any one thing you can keep into mind.
Okay.
So another is vice versa or opposite. Okay. There. Is it clear for you?
Yes.
There. That's all from this graph. You can just go through it. We'll move on to the next topic. Then what is the third point? The nuclear force between neutron, proton, and proton is approximately the same. There are possibilities, right? The force might be between proton, neutron, and proton and neutron.
Yes.
Right? It might be. But all are same. The nuclear force does not depend upon the electric charge. What is electric charge? What is electric charge? First lesson la full learn பண்ணிருக்கோம். What is an electric charge? Metals are said to be.
Yes.
So the metals are the
element gains or loses electron.
Gains வந்து electric charge கிடையாதுல. லூஸ் பண்ணாலும் அது electric charge மாறும்.
Gain for negative charge.
Absurd think பண்றாங்க. Metals are electrically possible. Metals are good conductors of electricity. Why? It is producing charges.
Yes, ma'am.
If an atom is gaining electron, then what will happen?
metals are there.
Metals இருக்க முடியாதுடா. Gain பண்ணுச்சுன்னா என்ன நடக்கும்? அது என்னது அது? இப்போ ஹாலஜன் எடுத்துக்கிறேன். ஹாலஜன் என்ன பண்ணும்? Gain பண்ணும். அது நான் மெட்டாலிக் குரூப்.
Yes.
Gain பண்ணுது. அது சார்ஜஸ் ப்ரொடியூஸ் ஆகாது.
Yes.
Cl இருக்கு குளோரின் 1 எலக்ட்ரான் அது கெயின் பண்ணுது. அது Cl மைனஸா மாறும். அப்ப அது நெகட்டிவ் சார்ஜ் நம்ம சொல்ல மாட்டோம். What I have taught you so far.
Yes, ma'am. Yes, ma'am.
So ஒரு ஆட்டம் இருக்கு அப்படினா ஒரு காப்பர் ஆட்டம் எடுத்துக்கிட்டீங்கன்னா அது 2 எலக்ட்ரான்ஸ் லூஸ் பண்ணுது. If it loses 2 electron, then this copper 2 plus acts as a positive charge as a whole, including 29 number of protons, okay, and then neutrons, and then 27 electrons. That is considered as a heavier mass of positive charge. These 2 electrons are said to be negative charge. Clear or not?
Yes.
That is electrical. So electrical charge ko idukku sambandham illa. That means what they are trying to say, we can apply it for any elements. Understood?
Yes.
Okay. Then okay, so unlike Coulomb's law or the Newton's law of gravitation, there is no simple mathematical form of the nuclear force. You cannot have any mathematical form. Like, what is the mathematical form for Coulombic force? Q1 Q2 by R square. That is K into, right? What is that next? Gravitational force.
GMM by
M1 M2 by R square. Like that, there is no definition.
Yes.
There is a definition, there is no mathematical expression. Okay. Then radioactivity, you know, right? Radioactivity is a process, okay, which exists in elements. So we used to call, there are natural radioactivity and artificial radioactivity also there. If there is radioactive supportive elements, then those elements are said to be radioactive elements. Maximum radioactive elements are used in right now medicine field, especially for treating cancers. They are using all the radioactive elements. Not only in this field, in industries and everything, it is useful. It's very, very really it is useful. After 1950, our scientific industry blooms into a technology. Okay, tech industries right now. Okay, all tech can enter into all field. So without tech, there is no medicine field right now. There is no industries right now. Clear? Okay. So there is no education institute right now. We are all using technology, right?
Yes.
Elsewhere tech enters. So this is the tremendous achievement of those scientists who have discovered all these nuclear explosions. Okay. Okay. So we'll see this. Henry Becquerel. So his discoveries are very nice discoveries. It is, you just keep in your mind all this name. Okay, Henry Becquerel, he discovered radioactivity in 1896 purely by accident. Okay, so while studying the fluorescence and phosphorescence of compounds irradiated with visible light. Understood? So Becquerel observed an interesting phenomenon after eliminating some pieces of uranium potassium sulfate. Okay, then with visible light. So visible light is actually in dual nature. You just go through that video. You might have seen one simulated thing actually there. How the light is incident on a metric orbit. Like a way on those days, all the experiments are carried out by means of all these things. If they want to learn, if they want to study the atomic structure or something which has to be done, so that is subjected under light. Because light only the ray which we can see. Other rays we can't see, right? There are X-rays, infrared rays, ultraviolet rays, then microwaves. So many rays are there, radio waves. We can make use of that. Okay? But the incident ray, if it is a light ray, then that will be the easy one for a scientist to observe.
Yes.
So that this light, that means visible region of an electromagnetic wave, and the spectroscopy plays a vital role. So what they did, they just pass on light on a metal target or on an atomic structure, on whatever it might be. Suppose if there is nuclear explosions or nuclear level atomic, nuclear level force, so whatever it might be, so that can be observed by means of passing a light into the substrate. Okay, then they just use some spectrometer to visualize all the spectrum which is emitted by it. Based on that spectrum or the output, they observe everything and then they did some calculations and then they came to know what is happening. Understood?
Yes.
So, and then they just predict some energies also emitted. Some heat energy is emitted. Or it's a kind of explosion is emitted. Okay. So that also done in the lab on those days. Okay. So based on all these experiments, they come to the conclusion and derive an expressions. So this is all a repeated experimental procedures. It is followed in physics. You might have seen. Okay, very easy to understand. See, what does it have? Actually, they said after eliminating some pieces of uranium potassium sulfate with visible light, then he wrapped them in black paper and separated the package from a photographic plate by a piece of silver. Okay, so what it says, first visible light is allowed to pass through and then incident on it, and then he wrapped them in a black paper. In a black paper means it won't allow any light, like. So I separated the package from a photographic plate by a piece of silver. Okay. Then when after several hours, why this photographic plate means it records it just record the negative of the image picture. Right now we are having all the monitor support. We can just live with the live moment, we can watch it out right now. The experiment will be. We can watch it out in a monitor. How the atomic structure will be. We can move the cursor and do with the monitor. Do check with the monitor. On those days there is no monitor. The only visibility can be done by means of this photographic plate. Photographic plate as a negative.
Yes.
Okay. Then here, when after several hours of exposure, the photographic plate was developed. Developed means on those days how the photograph was. Do you know? I remember still my mother's and father's, photos and everything. Okay, so they did their marriage on those days. They said they used to have a negative. They took a photo with the camera and then that negative will be developed. And then that negative has to be developed. That means it has to be made into a film. Then only you can see the image in a proper way. Unless otherwise no color is there, right?
Yes.
Okay. Have you all seen that negative of a photography?
Yes.
The same wise, here also you'll be getting photographic plate. That photographic plate has to be developed. Then only you can see the image. Okay. It shows blackening due to something that must have been emitted by the compound. Some black must be there. Okay, that shows what it shows. Something is emitted by the compound. There is some vacuum. Something is emitted by the compound. So iron was able to penetrate both black paper and the silver. Understood?
Yes.
Okay, what they did, Becquerel and his group and his team, what they did, first they took
Uranium potassium sulfate.
uranium potassium sulfate as a substrate, and then they allowed a visible light to pass through it. Then they observed everything. Then that is recorded as a photographic plate. Okay, in the photographic plate, that photographic plate is taken into, they separate that photographic plate and then kept in a black paper first. First they wrapped in a black paper. That's what it is given, right? Yes. And then separated the package by a piece of silver. So how they are just separating the plate means by a piece of silver only they are separating a plate. Unless otherwise if you touch the plate, then that will be causing something, right? Your fingers will cause some defects in that. Or if you just keep any other things, that will also react. And then it is highly, I think I supposed to say, that is, I mean, really hot it seems. Okay, you can't even touch with the hand it seems. Okay, so they use the silver coin. On those days, all the coins are made of silver. Do you know? Okay, pure silver.
Yes.
So he used pure silver to separate the photographic plate. Because on those days in a screen, the photographic plate means a film. Film means photographic film means it is very light in thickness. Plate means it is made of a high thickness and then. So the photographic plate is just fixed with the screen. So that I have just shown to you on that day about the spectrometer. We will discuss about the spectrometer. I will put one more video for that. Then you can imagine how the observations will be, how the spectrum is formed, how the screen is there. Okay, why there is a screen for all the experiments. Okay, so you can able to understand. So then that is recorded right now. So they removed the plate by means of a silver coin. That's all. So that it is given like that. Piece of silver. Okay. Then what will happen? You may see the blackening of something. There is a black in that particular photograph after developed. Okay. Then what will happen? The scientist, in the scientist's perception, they are thinking something is emerging out of it after wrapping with the black paper, so that it can emit beyond black paper as well as the silver also. Is it clear for you?
Yes.
So that it's highly radiated. So it can penetrate, right? Okay. So experiments performed subsequently showed that the radioactivity was a nuclear phenomenon in which an unstable nucleus undergoes a decay. See, this black dot only gives an idea for the scientist about what?
Radioactivity.
Okay, so that is the phenomenon. Radioactivity is the phenomenon. So it is occur in nature also. I told you, no? Naturally it may be occur. It is known as radioactive decay.
Yes.
That means something is, the compound is emitting some energy. So that the compound, the atoms of the compound is decaying. Okay, then. So we see alpha decay. There must be alpha decay, in which helium nucleus is emitted. Out of it you will be asked some questions actually. Okay. So alpha decay in which a helium nucleus is emitted. You know what is an alpha particle? Already we have discussed.
Yes, ma'am.
Helium is an alpha particle, right? So if helium is emitted, then that is known as alpha decay. Okay?
Yes, ma'am.
Then in which a helium nucleus. That's what they are saying. Okay. Then beta decay means, I have told you, no, beta particle means electron. So decay means electron is emitted.
Yes.
Electrons or positrons we can say. So these particles are the same mass as the electron. Positron means it is also an elementary particle which is present in an atom, which is same as that of the mass of electrons, then but with the charge exactly opposite to that of the electron. So positron has positive charge. Atom, there are so many elementary particles, baryons. நீ பார்க்குற அந்த பேரியம் particles. நிறைய இருக்கு, pions இருக்கு.
இதெல்லாம் எங்க இருக்கு?
ஆமா, there are so many elementary particles. Pions, mesons, so many things are there. Yeah, now only you are learning nucleus. So when we were in 12th standard, so we learned about all these elementary particles from our 10th standard it seems, on those days. Nowadays it was deleted actually, you are just learning right now. As a kid, that's what I'm saying. All of you do listen. Actually this book, this NCERT book is a summary. It's a kind of summary. That means the NCERT, they are just given this book to you, textbook to you as a summary, foundation, strong foundation. From this you have to understand and then you can just gain more knowledge so that you have to refer other reference books which is prescribed by NCERT. That's what we have given you as a book. From the prescribed books we have taken all the things and then we will be giving to you. You have to go through that also. Unless otherwise you can't get any full marks. Clear?
Yes.
Definitely 40% definitely will be tricky. Okay, that 40% from the reference book only. You can't say it is not in our book now. You can't say like that. You have to understand what it is. You know the link, right now. So there is a lot of links between the concepts.
Yes.
That is missed over here. That you have to find out from the reference books. But if you go through the SLR book, then that is this much content it contains, right?
Yes.
You can't able to understand properly. Even this summary also you can't able to understand because you are right now seeing, right? You are very new to this concept since you are very young enough to understand. So that it is given you as a summary here. Okay. So you have to you want to develop that summary into a deeper concepts. So that you have to use that prescribed book. That is what is the reference book? SLR. For example, I am saying. So SLR it's far beyond your understanding. So that we have given you the book which is more useful to you, like a spoon feeding, like your students' notes only, that is. From that book only, so many problems are discussed over here. From that book only, you will be getting, JEE questions also, NEET questions also, all the competitive kind of questions. Okay, but the syllabus is only fixed by the NCERT people, right?
Yes.
Same syllabus, but how do you feel the difference? You are saying when compared to board exam, all the competitive exams are tough, right? The tough level based on all these reference books. Okay, so do follow our book. Don't keep the book in your shelf. You just open and then go along with this. There are so many links. Okay, don't think if you learn from the book itself, it's okay. You can't even get 60% in your board exams, I'm saying. Okay, listen. So physics are very important. So when what is gamma decay? In which high energy photons are emitted? That is gamma decay. See the difference. What is the high energy? Hundreds of kilo electron volt. How much of energy is emitted, right? Okay. So nuclear energy, we are going to see the curve of binding energy per nucleon given in the figure. First figure we saw, right? 30 to 170, that is again discussed. Okay. You know that the difference in the total mass of a bound system, right? There is a mass defect. Okay. So there is a net energy release. Everything you know. So fusion also we have studied. Okay.
Yes.
Then fission and fusion, you know, exothermic chemical reactions underlie conventional energy sources such as coal or petroleum. You are just imagine like this. So what is exothermal chemical reaction? Exothermic means it is releasing energy while producing product, especially coal or petroleum. Okay, this is said to be conventional energy sources, right? You can see elsewhere in all the countries without coal and petroleum, nothing can be operated. Okay, so then here the energy is involved on the range of electron volts. Understood?
Yes.
So on the other hand, in a reaction, nuclear reaction, the energy releases of the order of the conversion of joules to electron volt, right?
1.6
Yeah. So that also you should keep in your mind for this lesson. Then on the other hand, in the nuclear reaction, the energy releases of the order of million electron volt. Kilo electron volt and million electron volt. What is the difference?
Million electron volt plus 1.6 into 10 to the power minus 13 multiply பண்ணுவோம். Kiloelectron
Million means 10 power 6.
kiloelectron
Kilo means 10 power
3.
3. Okay. So that's for the same quantity of matter, nuclear sources produces a million times more energy than a chemical source. See, I am reading from your book each and every line and then I am teaching you. You better go through all these things, then only you can able to learn properly. Okay. Then what is given? So fission of 1 kilogram of uranium, for example, it generates how much of energy?
10 to the power 14 joules.
Astonishing, right? So 1 kilogram of uranium, it is producing 10 power 14 joule of energy. Compare it with burning of 1 kilogram of coal that produces 10 power 7 joules. Double update. I mean, it's double in exponentials.
Yes.
Okay. Then this is fission. You know, fission means a heavier nucleus is splitted into 2 or more lighter nuclei. That is fission. Okay. New possibilities emerge when we go beyond natural radioactive decays and study nuclear reactions by bombarding nuclei with other nuclear particles. You are just imagine this is one nucleus. This nucleus is bombarded or collapsed by another nucleus. You know this nucleus contains positive charge. Nucleus. This nucleus contains positive charge. These two positive charge are repulsive.
Yes.
The force which is given, that nuclear force which is acting towards these two nucleus will be overcoming this repulsive force. Understood? So that this repulsive force we used to say that as Coulombic force. So the nuclear force should overcome the Coulombic force. Understood?
Yes.
Okay. So the most important neutron-induced nuclear fission is nuclear reaction is fission. Okay. Here what it is saying with other nuclear particles such as proton, neutron, alpha particle, etc. Okay. Then why we are considering alpha particle, alpha particle, alpha particle? Hydrogen doesn't contain neutron, right? 1H1 if you talk about.
Yes.
So that we are focusing helium. Helium consists of neutrons. How many neutrons?
1 neutron.
1 neutron, helium.
1 proton or neutron?
Helium. Correct answer.
No.
What is the mass number?
2.
For helium. Again you are talking about the atomic number.
4. 2 proton, 2 neutron.
2 protons, 2 neutrons and 2 electrons. Right?
Yes.
Okay. So then, a most important neutron-induced nuclear fission is nuclear reaction is fission. An example of fission is when a uranium isotope, uranium-235, 92. Out of it, you can express the element like here the atomic number, here the mass number, here the atomic number, right? So A is the letter designated for a mass number, Z is atomic number. Keep it in mind, fix
Yes,
it in
ma'am.
mind.
Yes, ma'am.
So then, what is it? Uranium is bombarded with a neutron. Okay, ma? So you consider another neutron.
Or neutron atom?
Either. No. You are considering. This from another element.
Oh, okay.
Clear? Clear or not?
Another element for helium
Ah.
possibilities.
Yeah.
Yes.
So you are considering that uranium bombarded with a neutron breaks into 2 intermediate mass nuclear fragments. What is that? See, for example, if these two bombarded together, then what will happen? So one neutron, if it is added, then it will be this 235 becomes 236 and 92. Now this is uranium-236.
Yes, ma'am.
It is not actually permanent, it is now split into barium and krypton. If you add these two numbers, you will find what is 144 plus 89. Make it fast. What is this? 233.
Yes.
So there are 236. Okay, what is the atomic number right now? Add this. 56 plus 36.
Yes.
92. This is tallied, right? Atomic number is tallied. That means it shows there is no deviation in number of protons and number of electrons.
Yes.
Then what is the difference?
Number of neutrons.
Neutron. So 3 neutron is emitted here. That is the case. Understood?
அது எப்படி மேம் அது ஒரு இந்த எலமெண்டே கிரியேட் ஆகும்.
ஆமா. Create agla. Actually, if the mass number is splitted, then that corresponding mass number is element. How the name is given da?
இல்ல மேம்
Based on the
அது
mass
இல்ல
number.
ஃபார்ம் அந்த எலமெண்ட் ஃபார்ம் ஆகுமான்னு கேக்குறாங்க.
Element. Ama, if the atomic number is there and then the mass number is that, then that particular element we have to say.
இப்படி எல்லாம் எலமெண்ட் ஃபார்ம் ஆகும்னு
Yeah, so this is actually nuclear fission, and then what will happen? The same reaction can produce other pairs of intermediate mass fragments also there. See here, like this also it may happen. Okay?
நம்ம அப்போ அந்த வேரியபிளா
Medium and
ஆர்டிஃபிஷியலா ப்ரொடியூஸ் பண்ண முடியும்.
Yeah, we are producing. Okay. So then another example, xenon and strontium. Okay?
Yes.
So barium, krypton is coming, then this rubidium and everything is coming, and then xenon and strontium is coming. So there are so many types of fragments we arrived. This is said to be a fragments.
Yes.
Okay. The products are radioactive nuclei. Again the products are radioactive nuclei. Clear? It is said to be radioactive. That means it may emit radiation. That is the meaning. What is the meaning radioactive? It may emit radiation. Okay. So the fragment products are radioactive nuclei. They emit beta particles in succession to achieve stable end products.
Electrons emit problem.
So it is actually this is fragment, right, ma?
Yes.
In order to achieve its stable products, okay, then it is radioactive, we said.
Yes.
Something radiation is coming out. So in order to achieve its stable end products, the fragments, they emit beta particles. What are beta particles?
Electrons.
So in succession means what is that? So it is going on like that. The process is in succession. The process doesn't end, okay, before the beta particle emission. Okay. So the energy released in the fission reaction of nuclei like uranium is of the order of 200 million electron volt. This is known as Q value. You better keep it in your mind and then take a note of this. So the fission reaction of nuclei like uranium is of the order of 200 million electron volt per fissioning nucleus. So this is estimated as follows. How much of energy is released from a uranium? 200 million electron volt. Okay. So then. Yeah. Yes. 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 So if A is 240, then two fragments it is divided. Okay. Then. So what is the binding energy? 7.6 million electron volt.
Yes.
So for here, for a fragment nuclei, it will be 8.5 million electron volt. Okay, then what is some energy difference? So there is some energy difference. So energy is gained over here, right?
Yes.
So gain in binding energy for nuclear is about 0.9 million electron volt. Okay? So that should be multiplied with the total energy means with the nucleus. So what is that? 260 million electron volt. This is the way you can calculate. Okay? Individually you can record the binding energy. Yeah, it is binding energy.
Binding na usually integrate பண்றோம்.
Yeah, that's what.
Release our energy binding energy.
No, the binding means if you bind one nucleus with another nucleus, then only the fission takes place. Fusion also will be there.
No.
See, for fission also, this is said to be fission, right?
Yes.
In order to split one nucleus, we need another neutron, another nucleus. Understood? So that is binding. You are binding one nucleus with another nucleus.
Yes.
Clear? Then, is it clear for you? Then nuclear fusion we'll see. So usually in celestial objects, you might have seen this fusion. This cannot be achieved naturally, very rare. Okay.
Yes.
So we'll see this. What is nuclear fusion? Energy generation in stars. We can see when two light nuclei fuse to form a larger nucleus, energy is released. You've asked, right?
Yes.
Ma'am, if two nuclei, like a nuclei fuse, then how come the energy is released? It is released. Okay. So this is nuclear level. This is something different when compared to another topic. Okay, ma, that's what this nuclear topic is something different when compared to the electrical topic. So that's what they are saying. It is not electrically applicable. Okay. Then. So since the larger nucleus is more tightly bound, as seen from the binding energy curve and figure, the first curve, you know, right? So some examples of such energy liberating nuclear fission reactions are. You do understand this. This is actually known as proton-proton reaction. Like a cycle it is. Okay. So 1H1 plus 1H1, it gives 1H2 plus 1 positron. What is it? This E plus is positron. Equal to electron, different sign. Okay, ma?
Yes, ma'am.
Okay. Then take a note of all these things in your notebook. Just take a note of this. Take a note of this.
திடீர் இந்த பாசிட்ரான்லாம் எங்கேருந்து சம்மந்தமே இல்லாமல் படிக்கிற மாதிரி இருக்கு.
Yes. So, what is it given? First one, what is it, ma? Here it is given deuteron, right?
Yes, ma'am.
So you know, right? Deuteron is present. So if the two hydrogen, protium or proton is fused together, then what will happen? Deuteron is released, deuteron is formed. Okay, it is a product, but so many things are released over here. This amount of energy is also released. But when compared to nuclear fission, this energy is somehow less. Or it might be greater.
Yes.
Or it might be, we can see. Okay. So in uranium fission, you may find how much energy is released. Near about 200 million electron volt.
Yes, ma'am.
So this is 0.42 million electron volt. Then 1H2 plus 1H2. You'll be getting tritium, right? So here clearly explained. You can go through it, right, ma'am?
Yes, ma'am.
Go through it. Then we will see this topic. I will catch you shortly once again.